Hello everyone, I am Joe Kim from Polytechnic Oklahoma. My metric number is 01 DDK 24F1069. Today I will explain about general skill topic 3, which is about BJT, also known as bipolar junction transistor. It has three terminals, which is base, collector and emitter. It consists of two types of BJT, which is NPN and PNP. So what is a BJT? A BJT is a bipolar junction transistor. It's a type of transistor that uses both electron and holes as charge carriers. It's a three-layer, three-terminal semiconductor device consisting of either NPN or PNP type configuration. The main function of BJT is to amplify or switch electronic signal. As an amplifier, it takes a small input current at the base and produces a larger output current at the collector. As a switch, it can turn on or off the flow of current between collector and emitter based on the base current. There are two types of BJT, which is PNP and NPN. For the NPN transistor, it has two N-type layer and one P-type layer, which is two negative and one positive. So how do the NPN work? It amplifies current or act as a switch when the base is given a positive voltage, which allows a larger current flow from collector to emitter. The majority carriers are electron, which is charged negative. NPN only activates when the base is more positive than the emitter. For PNP type transistor, it has two P-type layers and one N-type layer, which is two positive and one negative layer. How does the PNP works? Almost same as NPN, used to amplify or switch current, except the base is given negative voltage, which allow a larger current flow from emitter to collector. The majority carriers are holes, which is positive charge. How does the PNP activate? It turns on when the base is more negative than the emitter. In short, NPN current flow into the base. PNP current flow out of the base. So what is the key difference between PNP and NPN? First is polarity. For NPN transistor, it uses negative voltage for forward biasing, while PNP transistor use positive voltage for forward biasing. Second is biasing. For NPN transistor, the base emitter junction is forward biased by applying a positive voltage to the base relative to the emitter. For PNP transistor, the base emitter junction is forward biased by applying a negative voltage to the base relative to the emitter. Third is current flow. In NPN transistor, the majority of the current is carried by the electron, while in PNP transistor is carried by holes. In essence, the NPN and PNP transistor are function similar, but they're different in the material configuration and the polarity of the biasing required to operate them. Now I will explain about the function of the three terminal of BJT, which is base, emitter and collector. So for the base terminal, it acts as a control terminal. When a small current flowing into the base can modulate a larger current flowing between the emitter and the collector. In essence, it controls the transistor on or off state, which means it's like a switch. So for the emitter terminal, the primary function is to supply charge carriers which are the majority carriers, either electron in NPN or holes in PNP. These carriers are injected into the base region. So for the collector terminal, the collector role is to collect the charge carriers that has passed through the base from the emitter. Is typically connect to a voltage source and the current flowing from the collector to the emitter so that it can be amplified or switched by the base current. Advantage of the BJT. BJT offer high voltage gain, good performance at high frequency, and high current density. Now let's move on to the experiment part to find the base of the 4 transistors. First, we put the red probe at terminal 1 and the black probe at terminal 3, which the multimeter show the value of infinity. Next, we put the red probe at terminal 2 and the black probe at terminal 1, which show the value of 75 ohm. Now we put the red probe at terminal 2 and the black probe at terminal 3. The value show 70 ohm. Next we put the red probe at terminal 3, the black probe at terminal 1, which shows the value of infinity. Next we put the black probe at terminal 2, which show the value infinity. So for the transistor BC107, the base is the second leg. Okay? And this is a NPN type transistor because the base is the positive. So for the transistor 2N2222, the base is the second terminal and the collector is the first terminal, the emitter is the third terminal. So for this is a NPN because the base is the positive. Okay, now we find the base for the BD135. First, we put the red probe in terminal 1 and the black probe in terminal 2. And the value show infinity at the multimeter. Next, we put the black probe on terminal 3. The value is also show infinity. Next, we put the red probe on terminal 2 and the black probe in terminal 1. The value also show infinity. Next, we put the black probe on terminal 3. The value is also show infinity. Next, we put the red probe at terminal 3 and the black probe on terminal 1. The value show 60 ohm. Next, we put the black probe on terminal 2. The value show 60 ohm. So for the transistor BD135, the base is the third leg, the collector is the second leg, and the emitter is the third leg. So this transistor is a NPN because the base is positive. Okay, now the transistor BD140. First, we put the red probe in terminal 1 and the black probe in terminal 2. The value in the multimeter is infinity. Next, we put the black probe on terminal 3. The multimeter shows the value of 60 ohm. Next, we put the red probe on terminal 2 and the black probe on terminal 1. The value shows infinity. Then we put the red probe on terminal 2 and the black probe on terminal 3. The value is 60 ohm. Next, we put the red probe on terminal 3 and the black probe on terminal 1. The value in the multimeter show infinity. And last, we put the red probe on terminal 3 and the black probe on terminal 2. The value show infinity. So for the transistor BD140, the base is the third leg, the collector is the second leg, and the emitter is the first leg. So for the BD140 is a PNP because the base is a negative. In conclusion, in this experiment, we use a multimeter to find the base, collector, and emitter of a transistor. We check the connection like diodes. The base was the terminal. They show the reading with the other two. Then by comparing the reading, we identify the collector and emitter. We also identify the type of transistor, whether NPN or PNP. This helps us to understand how a transistor is built and how the terminal is working.